has been prepared as part of supplementary material for our paper titled Revenue Maximization with Optimal Capacity Control in IaaS Markets, published in IEEE Transactions on Cloud Computing, a special issue on cloud economics. IaaS cloud provider offer different pricing plans and purchasing options. For example, on-demand pay-as-you-go, that customers acquire resources on demand and based on flat rate prices. Reservation plan, that users pay upfront money to reserve resources and they utilize reserved capacity based on need in future. And recently, spot instances, which allow customers to acquire resources in auction-like mechanism by submitting their bids. The problem here is how cloud providers should allocate capacity to different pricing plans in order to maximize revenue. This problem is complex as different pricing plans generate different revenue per unit of capacity, and provider has different commitments and liability for different plans. For example, guaranteed availability for reservation plan, or provider is able to terminate spot instances whenever they require them. The problem we are going to tackle in this paper is, with limited resources available and considering dynamic and stochastic nature of demand, how revenue can be maximized by optimal allocation of capacity to each pricing plans. On-demand requests generate the highest revenue, so we should accept them as much as possible. Spot instances can be terminated whenever underlying resources is required. So to tackle the problem, we do admission control for reservation requests. We propose a revenue management framework. We frame our algorithmic contributions within the revenue management framework. We present a stochastic dynamic programming based on Markov decision processes. However, we show that even though stochastic dynamic programming is optimal, it is computational interactable. We propose two heuristic algorithms called heuristic and pseudo-optimal. We evaluate our proposed framework using large-scale simulations in Cloud Sim and cluster usage traces of Google and pricing conditions similar to Amazon EC2. Here we show some results. This figure illustrates that when resources are limited, up to 80% revenue increase can be achieved using our heuristic algorithms. This figure shows heuristic algorithms are able to achieve around 80% efficiency of optimal algorithm. In conclusion, our results suggest that significant revenue increase can be attained with the proposed revenue management framework when there exists sufficient resource contention in the system. For future, we'll look into modeling customer reactions to reservation request rejection. Do they switch to other plans or other providers? And we look into how our method can be used in support of investment decisions on extending the infrastructures for cloud providers. We also look into overbooking strategies. Thank you so much, and this is the information for accessing this paper, DOI, and you can download it from IEEE website. Thank you so much again. Bye.